every theorem has what we call the converse. So there is a theorem and then there is a converse. For instance, let's try and state the theorem of Pythagoras. It works like this. I'll just put it here. So the theorem states that in a right-angled triangle, the sum of the squares of the shorter sides is equal to the square of the hypotenuse or of the longest side. So this is a theorem. We're just stating some facts which can actually be proved. So in a right-angled triangle, the sum of the squares of the shorter sides is equal to the square of the longest side. And now the converse of that theorem is something that is stated kind of in reverse. Like in this case here, we are saying in a right-angled triangle, all that happens, this happens. So in a right-angled triangle, we expect all this to happen. Okay, guys? So now the question is, if all this happens, what does it mean, or what does it imply? I'll say that again. So we are saying, if you read the theorem, it says, in a right-angled triangle, all this happens, right? What happens in a right-angled triangle? What happens?
So you use the methods.
The sum of the squares of the shorter sides is equal to the square of the longest side, right? So what happens in a right-angled triangle? Right. And now tell me, if this happens, then what do we know? Then we know that that is a right-angled triangle, right? Because this here only happens in a right-angled triangle, right? So if you meet a triangle and all this happens, then you need to conclude that that is a right-angled triangle. So that is kind of the reverse. Do you see that we're kind of reversing the theorem? And we call this the converse of the theorem. And this, again, guys, is very important for the following reason. We are going to use this to prove that a triangle is right-angled. Right. So how do I tell that a triangle is right-angled? What do I look for? What do I check? What happens in right-angled triangles?
All that.
The sum of the squares of the shorter sides must be equal to the square of the longest side, right? So that happens in a right-angled triangle. So if I give you a triangle and you want to know whether it is right-angled, then check whether the sum of the squares of the shorter sides will add up to the longest side. You get it? Right. I want us to determine, as an example, determine whether the following triangles are right-angled. Are right-angled or not? Okay, so we can answer this kind of question if we know the converse of the theorem of Pythagoras. Right, so somebody draws something like this, and they make this one equal to 1, and they make this one equal to 4, and they make this one equal to, I'll say, 2. Let's call this point A, that point B, and that point C. Do you think triangle ABC is right angled? We will check that, right? And if it is right angled, which sides would actually meet at 90 degrees? Look at that triangle there. That's a right angled triangle. Do you see where the right angle is? Where is it?
The shorter sides.
The shorter sides form the 90 degrees, right? So in this example here, if this is a right angled triangle, then where would the 90 degrees be? At what point? At which point? Like in this case, so yes, so if this were to be right angled, then the right angle would actually be at A, right? So what you do then is take the shorter sides. This is the method of answering this question. Right, take the shorter sides and square them and add them up. So the first one is 1 squared, the second one is 2 squared. We do that and get our answer. What is our answer? 1 squared plus 2 squared equals 5, right? Then you take the longest side. The longest side in this diagram is 4. So 4 squared is equal to 16, right? Then you compare. Is the sum of the shorter sides, is the sum of the square of the shorter sides equal to the square of the longest side? Nope. 1 squared plus 2 squared is not equal to 4 squared, right? So 1 squared plus 2 squared is not equal to 2 squared, sorry, to 4 squared. So what is our conclusion? Therefore, triangle ABC is not a right-angled triangle. Okay. Here is triangle ABC. I want us to check whether this is a right-angled triangle. Is triangle ABC right-angled? And we are going to use the converse of the theorem of Pythagoras. So remember, the method is we take the shorter sides, square them, add them up, get the answer. Then take the longest side, square it, and get the answer. Then compare the answer from the shorter sides to the answer from the longest side. If the answers are the same, then the triangle is right-angled. Tell me for this particular one, if this happens to be right-angled, where will the 90 degrees be? Yes. The 90 degrees will be at C, right? Right, it will be there. But you see, if you look at that, right now, it looks like that is an acute angle. That could be a case of a poor diagram or drawing. So let's check. So let's take the shorter sides. The shorter sides are 3 squared plus 4 squared. 3 squared is 9 and 4 squared is 16. And this gives us 25. Okay, good. Then let's take the longest side. The longest side is 5. What is 5 squared equal to? 25. How do they compare? Do you see that 3 squared plus 4 squared is equal to 5 squared? Okay, because that is what we are getting from there. So 3 squared plus 4 squared is the same thing as 5 squared. Therefore, what can we say? Triangle is a right-angled triangle. Good. So this is a right-angled triangle. And where is the 90 degrees? Okay, so that is a right-angled triangle at C. Okay, guys, the numbers, because then these numbers become special. The smallest number there is 3, followed by 4, followed by 5. We can put them together like that in that ordered set, and then we call them Pythagorean. How many are they? There are 3, so let's call them triples, right? So these are Pythagorean triples. So I could ask the same question this way. I could say, is 3, 4, 5 a Pythagorean triple? It is the same thing as saying, is that triangle right-angled? So these are Pythagorean triples. Please take note of the terminology. Okay, then let's check here. Do you think 1, 2, 3 is a Pythagorean triple? You check like this, you say 1 squared plus 2 squared. What answer do you get? You get 5, just a 5, right? Then you take the longest side, it is 3 squared. What is 3 squared? Is 9. Now 5 is not equal to 9, therefore it is not a Pythagorean triple. Okay, good. What about, I want you to check this one, 6, 8, 10. Is 6, 8, 10 a Pythagorean triple? It is. Okay, what did you do? You said 6 squared plus?
6 squared plus 8 squared.
Plus 8 squared. What is 6 squared plus 8 squared? That is 36 plus 64, which is equal to 100, right? Okay. Then 10 squared is also equal to 100. So yeah, 6 squared plus 8 squared is equal to 10 squared. Therefore, this is a Pythagorean triple. Right, I need you now to get your own Pythagorean triple. Start from 3, 4, 5. If I start from 3, 4, 5, suppose I multiply each of these by 2. What do I get here? 6. What do I get there? 8. What do I get there? 10. Did we say 6, 8, 10 was a Pythagorean triple? Yes. What about if I multiply by 3? 3 times 3? 9. 3 times 4? 12. 3 times 5? 15. Do you think 9, 12, 15 is a Pythagorean triple? Are you sure? You will need to check that. Multiply by 4. 3 times 4? 12. 4 times 4? 16. 20. So is 12, 16, and 20 a Pythagorean triple? Yes, you can check that. So you can keep on multiplying. So what do you think about 3k, 4k, and 5k? I want k to be a natural number. You remember natural numbers? Right, what do you think? Do you think this, if k is a natural number, obviously, if k is a natural number, then it is bigger than 0. Natural numbers are your numbers 1, 2, 3, 4, 5, and so on. So if k is a natural number, then do you think 3k, 4k, and 5k are Pythagorean triples? They should be, right? Okay, but if they ask you to prove it, how would you prove it? Prove that 3k, 4k, 5k is a Pythagorean triple. It's like a triangle measuring 3k, 4k, and 5k. We take the shorter side, right? Which is 3k squared, correct? Please write it in brackets. So that is 3k squared plus 4k squared. So we need to simplify this one first. Right, what is 3k squared? That should be 9k squared, right? And 4k squared should be 16k squared, correct? Simplify that. You'll get 25k squared. Right, now take the longest side, which is 5k. So if you take 5k and you square it, you will also get 25k squared. Okay.